All right. Again, welcome everyone to today's webinar, Inpho 5.4, an image worth a million points. My name is Gregor Wilhaug. I'm Software Product Line Manager at the Trimble Geospatial Division. And our presenter today will be Thomas Koch, who will guide you through all the new functionalities in the new release of Inpho. Thomas Koch is the product manager for the Inpho suite. He has a background in photogrammetry, actually comes from a photogrammetry family with his father being involved in camera development. He joined the Inpho team in 1998 and went through a number of different positions within that team to his final position today as a product manager for the Inpho suite. Before I hand over to Thomas, I would like to give you a quick overview of the geospatial division and product portfolio. So within the Trimble Geospatial division, we actually covered the entire geospatial workflow from data collection over data processing to information extraction for both the land, aerial, as well as the satellite workflow. In the land area, we have mobile data capture hardware for both imagery and laser scanning. For the aerial part, we have aerial cameras as well as laser scanning and imaging platforms. And on the data processing information extraction side, we have software packages which are focused on the land side, the airborne data processing, and the information extraction side with Trident Analyst, Inpho, and eCognition. With that, I hand over to Thomas to guide you through the actual content of what's new in the Inpho software. And with that, I hand over.
Okay, thank you, Gregor, for the introduction. So, first of all, welcome also from my side to all of you who have decided to join our today's webinar. I know for some of you it's still early in the morning, while others are probably about to go to bed. Nevertheless, thanks for registering. So let me start. So what drives us these days in photogrammetric software development? In the recent years, computer hardware was really developing so fast, and that actually enabled us to now use different algorithms and technologies with a suitable performance that was not possible earlier. For example, also parallel processing capabilities of the latest hardware that serves for a big improvement in terms of software performance. These are, of course, things that we addressed in our latest release. Another important factor, Gregor already mentioned that, is, of course, that the Geospatial division inside Trimble is a really solid piece, and we really benefit from a variety of synergies to build a unified geospatial workflow from A to C. You see that right here from a point of data acquisition with our aerial cameras, airborne, mobile laser scanners, and so on. What we want to focus on today is more the data processing part with our Inpho software, and then, of course, there's the information extraction with eCognition. Talking about this workflow, of course, you can use the data that's coming out of our Inpho process for the information extraction in eCognition, but also the other way around is possible, that, of course, we can use the technology from the information extraction in our products in Inpho. To have that complete geospatial workflow available, of course, is a benefit for us, but also, of course, it brings much more value to our customers. Talking about this Inpho data processing part, of course, we have a complete high-level photogrammetric workflow, starting from the aerial triangulation, which is completely automatic, the automatic high-density surface model generation from imagery, automatic city modeling, as well the mass production of seamless through orthophoto maps, and additionally to that, we have an outstanding DTM and LiDAR processing engine available. So what we are here for today is that we want to present, of course, the Inpho 5.4 version, our new version, which is delivering vastly improved performance and, especially workflow integration and result quality. That release is available since the 1st of September 2011, so already some days ago we released that software. And, of course, all our users with a valid maintenance contract will get that software for free. Now, just to quickly tell you what else you can look at if you need to have more information about our software, about that new release. There is, of course, the press releases you can read in any papers. There is a What's New PowerPoint presentation available from our internet site, and as well as What's New datasheet. There are also the release notes with all the tiny little details described for that new version. You already, I guess, got an email information about that, and actually you're right now joining a webinar, one of several ones that we did. So, okay, let me start with some highlights of this new version. So, first of all, let's talk about the high-density point clouds. So in the past, we already had very, very good results in the DSM generation, but as I mentioned, the new technologies in the computer hardware, the much better hardware that we can use today, enabled us to now implement a cost-based matching strategy, which is able to extract point clouds from images with a density of up to 1 point per pixel. That's extremely dense, of course. And that might probably be a low-cost alternative to LiDAR data. The benefit for that would be, for example, in the true orthophoto production or also in the automatic feature extraction. Let me come to those points a little bit later. So, yeah, this image that you see right here could probably be derived by a LiDAR scanning device, or well, probably it's coming from image matching. So if we look at that, yeah, well, in fact, that's an alternative to LiDAR technology. It is a point cloud that was derived by MatchT DSM. So in this little graphics that you see right here, if you look carefully, there are those little paths where those agricultural machines were going over the ground. So you see how much detail is in this point cloud. And yeah, like I said, so that's derived by image matching. That's not a point cloud coming from LiDAR. On this slide, I tried to mention or to highlight only the 5 most important points in this new MatchT release. So starting with that we create now a density of up to 1 pixel ground sample distance. This means that, say, if you have a camera that is able to capture images at a ground sample distance of 5 centimeters, you will also get a density for your surface model of 5 centimeters. Then, as a next point, this point cloud that we generate is now extremely homogeneous. It's a grid-like distribution, actually, that we have. That also produces very sharp edges at the buildings, and along with that we have a very low noise ratio, so the noise in the data is much better than what we could achieve before. And normally you could imagine, or people normally think, that if accuracy, density, everything is getting better in a software product, then also it will normally be slower than before, but actually the opposite happened in our software, so we're also 10 times faster than before. Just a couple of days ago, I've been asked, well, what would you do with those millions of points with this extremely high density? Where's the benefit for that? And so I decided to just tell you 1 or 2 actual use cases, or 1 or 2 places where a dense point cloud like that could really be a benefit. First of all, right here, there is the building generator. So the building generator is our tool to automatically create level of detail 2 city models from LiDAR data and shapes that we need. So actually, what do we need to create those city models is the true ground points. We need to have the surface model, which could, for example, be derived by MatchT DSM. And we're using shapes that are probably derived from a cadastral map. And it's easily to think that if the surface model is extremely accurate, so if I have sharp edges, all the tiny little details represented in the surface model, then of course also the success rate of a building generator is much higher. And we're talking here about a success rate of about 90 to probably even 95% success rate. But it's not only the surface model itself, it's also the ground model that will probably be better, as I have a much better surface model available, so the buildings and so on are represented much more accurate. So also filtering algorithms to get the true ground can be performing or outperforming much better than what you would have with a less accurate surface model. So in that complete workflow, these high-density point clouds really are a benefit. Just another comparison that I have right here, or another example, is using the new Match TDSM for a direct true orthophoto computation. So what I did here on that slide is I'm comparing the former 5.3 version with the new 5.4 version in terms of creating a direct true orthophoto completely automatic. So on the left side, you see on that little screenshot or in that picture, this is a true orthophoto that was generated with an old point cloud. And if you look carefully on the street, you still see those roof parts lying on the street. You see that there are some wavy lines, or the edges of the buildings are actually not very nice represented, and so that's most probably not a result that you would accept or that you would provide to your customers. And if I'm comparing that to the 5.4 version on the right side, you see that there are no more of these roof pixels lying on the street. The edges of the buildings are more or less straight, and so that might already be some product that you really sell to your customers directly. And just keep in mind, I wasn't doing any editing here. I just used all the results like they're coming out of the software without any manual interaction. And also keep in mind that this product is derived from a 20 centimeters photo flight. So considering that our new cameras that we have available on the market are able to capture ground sample distances of 3-5 centimeters, then also this result for direct true orthophoto would be extremely good. So just from some point of view, what's concerning the real efforts for true orthophoto generation, of course, what so far was the major point, the bottleneck, is to create the surface model, which had to be derived, for example, by digitizing the roof lines and things like that. And yeah, most probably with that new Match TDSM point cloud, that's no longer necessary, as that could be a completely automatic process. Now, I was talking about the improvements of the point cloud, and so let me just show some other examples. So on the left here, you see again a graphics that is comparing the point clouds from the old 5.3 version with the new 5.4 version. The red points are the old ones and the green points are the new ones. And you can easily see that the noise is much better in this new data set. Also, looking at the right side, so there is, in this high-colored view, clearly a noise seen in the 5.3 version where the roofs are. There's also that church tower, which is, well, looking, it's already in the data set, but it's not really looking very detailed. It's not looking very nice. And if I compare these to the graphics underneath that, so there is the 5.4 version where I really have a nice representation of the roof, and also the church tower is clearly visible with all the details. And yeah, normally you would think that, well, just smoothening the point cloud is looking nice, but you're losing a lot of details, of tiny details. But again, here the opposite happens. If you look at the rest of the church building, there are a lot of details visible in the 5.4 version, which were not visible in the 5.3 version. And that's why I say, okay, we have a better point cloud concerning the noise ratio, and we can still maintain the little details. So that's a very good thing, of course. Then I said, well, we improved the density of the point cloud and the homogeneity. Sorry for that slide. There was something going wrong, but anyway, I can tell you that. So, yeah, talking about the point density in 5.3, we had a minimum distance of 5 pixels here. That means that, according to the matching techniques that we were using, so that was least squares matching and feature-based matching, the points that were extracted are usually only represented at the edges of gray values. So you see that clearly in this little height-coded view. There are holes in the DTM data, so only along the gray value edges there are the points. And so it's a very inhomogeneous distribution of points. Whereas underneath that, in the 5.4 version, we have a minimum distance of up to 1 pixel. The default value is 3 pixels in order to keep the file sizes or the amount of data a little bit lower. But like I say, so we can create a DSM of up to 1 pixel density, and we have a very homogeneous distribution, which is, grid-like, like I said. And this homogeneous distribution is helping us to get a better segmentation of the data. You will see that later in a use case. And we, of course, create much better edges along the buildings. Another thing that I already mentioned is we got, of course, a better accuracy, and this went together with a better performance. Just to emphasize that a little bit, I made 2 comparisons. The first is on that slide right here. So I compared just the standard run with the old 5.3 version and the new 5.4 version. The density was 1 meter compared to 0.6 meters. So we get a denser DTM. And then looking, for example, at the 3D points, that's a tremendous difference. So we went from 18 million points to now 79 million points. The estimated height accuracy is went a little bit better. So we're now from 16 centimeters to 12 centimeters. And if I'm looking at the elapsed time for that, so we had formerly a computation time of 557 minutes, and we went down to 66 minutes only. And this is just one view on the performance. I could make another test just trying to extract the DSM with almost the same accuracy. So actually what I did is I was running the 5.3 version down through the complete image pyramid just in default, and the 5.4 version, the new version, I ran only down to the second highest resolution level. So the density is getting a little bit worse than before, but looking at the 3D million points, the 3D points, I had formerly those 18 million points, and now I'm about 20 million points, so that's more or less comparable. Also, the height accuracy, 16 to 19 centimeters, is fairly the same. And now if you look at the elapsed time, which was going down from 557 minutes to only 14 minutes, that's really a tremendous difference. And so if somebody just needs the same accuracy like he needed that before in the 5.3 version, if this is enough, then you have a tremendous difference in terms of computation time. Okay, so that was the first major part of the 5.4 release. The second part that I want to highlight a little bit more is the large data handling. So, of course, as you can imagine, using these cost-based matching strategies, creating denser point clouds, and also the situation that we have more and more data to process in always smaller time frames, we had to do a lot of enhancements in our parallel processing capabilities. And again, the computer hardware was helping us a lot in that aspect. So looking at the figures right here, for example, we see that, for example, in the orthophoto production, some tasks are even 40 times faster than before. So we really did a lot of improvements concerning the performance in all our modules. Also talking about the filtering process, we will see that on one of the next slides here. And of course, using new data formats, for example, big TIFF support for larger images, and also using the tile navigation system that we already introduced some versions ago. We are now using this TPIX format also throughout the complete system. So, for example, in the orthophoto generation and mosaicing part. I was talking about the filtering with our new Inpho DTM extension. This filtering method allows us to now filter 1 square kilometer in any case less than 1 minute. So we have done a lot of improvements just to get a faster filtering computation there. And this goes along with an automatic gap filling option. So that means if we are looking at that workflow that's highlighted here, on the left you see the match TDSM. And this is going through some filtering step, and of course everywhere where I have some buildings, you can clearly see those holes in the data. And these holes are then automatically filled with this gap filling option, re-interpolating points in there, and so you end up in one automatic process with a nice looking ground model. What's not the emphasis right here, but I still want to mention that also in this Inpho DTM extension, there's now the contour line generation, to simply create cartographic contour lines. Let me then just show you some information about the productivity in our author box. So we made some tests with about 4,500 UltraCam XP images, just standard 3-channel 8-bit images with a resolution of about 10 centimeters. That photo flight was with 70 by 30% image overlap, and we were just using an off-the-shelf computer, so nothing special. And looking at the productivity right here, again, we are looking here at a complete orthophoto process, so starting with the orthophoto generation and doing the mosaicing. So that's just the figures for that complete workflow. If we're looking at that, we are able to process about 1,271 orthophotos per day on a usual SATA drive, and on a network drive, still it's more than 1,000 images per day. So we, again, did a lot of improvements talking about the productivity here. But just enhancing the automatic capabilities is often not enough. So just here on that slide, you see some examples of a good and a worse seam line. So the good seam line, of course, has to avoid the buildings, it has to avoid the cars on the streets, and so on. And on the right side, you see that there is a seam line passing through a building, and these are, of course, usually things or areas where you need some manual editing. Now, coming back to computation times and processing times, of course, now if I'm looking at that graphics here, processing the orthophotos is taking a considerable amount of this total time that we have. So, of course, it's looking like that we could further improve the speed of processing the orthophotos. But if I take into account the cost that I have, so that's on my next slide right here. So, looking at the costs that I have, I can clearly see that labor times are driving the costs and not the automatic times. So, looking at that right here, of course, the better my results are getting, and the more I support the users in also doing a good editing, to have a good workflow for everything, to avoid some manual interaction, then of course this is the best practice to save some costs to get a better product at a cheaper price. And that brings me to the next part right here. So the next thing that we were working on in our 5.4 release a lot was enhancing the usability and providing better workflows for all the interactive parts, and also the workflow between all the modules and all the software packages we have inside Geospatial. So starting with for example, Match AT for the automatic aerial triangulation, we have a much better graphical analysis, so we enhance that. That, of course, increases, again, the efficiency for the quality assurance. Also, the point cloud viewing in DT Master and the DTM editing or a point cloud editing tool was getting a much higher resolution, and therefore it's much easier to detect areas where I probably need some editing. Then there is a lot of things done in the orthophoto computation parts where we have more intuitive tools to do pre-enhancements to the images. And finally, for example, there is an email notification available now for all our modules, so you can monitor your process status from anywhere where you are. So instead of probably starting a process on Friday and you're coming to your office on Monday and you see, well, okay, your process did not finish because some data was not correct or whatever, you can get that status message directly home, and probably you can react to that much earlier than just waiting for the day when you get back to work. Okay, I was talking about some orthophoto or orthobox features. So to really get a better usability, right here you see the macro editor for the radiometrics editor. So the radiometrics editor inside the orthobox is used to pre-enhance the images a little bit to help getting a more homogeneous distribution of gray values, of colors, and so on in the orthophotos. And just before in the older versions, we had to load all the images that needed some editing. And now actually what we can do is we're selecting just a couple of these photos that need some enhancements and record a macro, so recording what kind of editing we're doing, and we apply that macro then to the rest of the images. So in fact, you only have to load a couple of images, I don't know, probably 10, 20 images to the radiometrics editor and apply that to thousands of images. What you see right here, so on the top side there is this data set where you clearly see there is a couple of images which are much darker than the others. So that's probably coming from 2 different flight dates, and just selecting some 10 images, recording the macro to enhance those images a little bit, and applying that macro to the rest of the data is providing then already somehow homogeneous result, and AutoVista can then do the fine work to enhance all the little differences between the photos. Okay, another new feature in the orthobox would be that we are now using an adaptive blending, not only in the automatic seamline detection, but also when I have a manually measured seamline or an edited seamline. We are no longer using only the fixed blending option, which clearly makes a seamline visible, but we are right now also using this adaptive blending, and so you easily see that on the right side there is the seamline is more or less perfectly hidden. You still see some kind of shadow in there, but that's really acceptable, and you get a much nicer looking mosaic with that, of course. Okay, and now let me come to this use case that I was talking about. As a use case, I want to present you some workflow for a cadastral map update, just to demonstrate also what's the benefit of having now inside our Trimble Geospatial division that complete workflow available. So, of course, a cadastral map update is something that is always required. So having up-to-date cadastral maps, that's an essential task. And these tasks are so far not at all automated. There's no standard how to do that, and therefore we have high labor costs. And so just depending on who's working on that, the results will always look different. So here on the right side, you see probably there is, in between half a year, somebody just built a new house on top of a street. That's a lucky guy because he has 2 entrances, one in the backyard, one at the front of his building. But yeah, of course, these changes need to be monitored, and somebody needs to react to that. Yeah, so coming back to our workflow. So of course, just to start a campaign or to start that workflow, there will always be then the aerial survey with a planning phase. So of course, we have all the tools available to do the flight planning. Then there is the survey itself with, say, for example, our Harrier system with the DSS or the Trimble aerial camera. Probably you joined the webinar about our camera yesterday, so you got some information on that. Yeah, and then there are also the quality control tools, all those tools available that are required to do the survey itself. Good. What we wanted to look at a little bit more is the data processing part. So while we are looking at our Inpho software with the full automatic aerial triangulation, doing the DSM generation, AutoMaster for the orthophoto rectification, AutoVista for doing the mosaicing, the tiling, and the color balancing, and that, as a result, will give us, for example, in our use case here, our orthophotos with some 20 centimeters resolution, a DSM point cloud with the same resolution, and a DTM that we were deriving automatically from that with 1 meter resolution. And this data that we were producing with our Inpho suite is now used in our eCognition software to do the change detection. That change detection inside eCognition is a fully automatic process. There is an optional post-adjustment possible, so whenever your imagery is probably looking a little bit different than in the project before, so the radiometric values are changing a little bit, for example, then you can easily adjust those settings a little bit, and you immediately see how your classification is changing. And then, of course, you need some tool to visually check and edit your classification result. Let me zoom into that a little bit. Okay, so you see here a customized user interface for exactly that task, to do the change detection. So on the right side, on the left side, you see those little thumbnails where you see all those changes that were detected. You can use your keyboard to go from change to change. And on the right side, you see the detailed view, depending on the data that you have loaded. So you can check if your change that was detected is really a valid change, if you want to reject that, if you want to accept it as a valid change, and just go through that quality analysis step very quickly. I said that's a customized user interface. All the users using that tool can create their own user interface for that, or they could also use our professional services team to let them create some customized user interface for their specific task. Yeah, let's now look on what were the improvements in this change detection process now using the Inpho 5.4 version instead of using the 5.3 version. So first of all, there is a higher processing speed. We already talked about the processing speeds in the Inpho software itself, but also in eCognition we have about 7 times faster computation of, for example, the rasterized surface model. And together with that, we also get a much higher accuracy or much higher success rate of detected changes. Again, here, if I'm looking at that a little bit more closely, so on the left side here you see the result with the DSM that was coming from the 5.3 version. And for example, on the streets, you see in yellow there are a lot of buildings or detected changes, so it seems like if there would be a new building, which is of course a misclassification. And now looking at the right, there's the result that was generated with the new DSM point cloud, and you can clearly see that along the streets, for example, all those misclassifications are gone. So it's a much higher benefit that I get from this Inpho 5.4 version, just because I need much less editing and much less efforts to check all the data. Okay, then staying in the workflow, okay, the final step is then doing the surveying. So we have detected the changes in our software, and then we can send out the field surveyors doing all those surveying work and updating the cadastral maps themselves. So that's, of course, not part of the geospatial division, but it's still part of Trimble. So, yeah, it's still under one umbrella. Okay, the benefits for that complete workflow that I presented now is that we have an automation of all those time-consuming image processing steps. With this automation, of course, you have a standardized workflow of the change detection, and you can reduce all the efforts that you had to manually interpret and compare all the data. Okay, so of course that was a use case, you might say, and this is all looking nice. But actually, this test that we did that for the state authority of Rheinland-Pfalz, who wanted to check our capabilities in here. And just to show you that statement, what they gave us is eCognition and Inpho software allows us to automate time-consuming image processing workflows. Furthermore, change detection of cadastral buildings, land survey register with eCognition can be standardized, and the effort for visual image interpretation and field comparison can be reduced. That was, of course, the goal that we wanted to achieve. And yeah, so the state authority was happy with what they saw, and of course we were happy that we really could fulfill all their needs. Okay, so finally just some questions and answers, just some general things that I wanted to go through before you can really ask your questions. So first of all, some of you might think, well, where are those old version numbers that we had, and what actually is the meaning of Inpho 5.4? So Inpho 5.4 is the brand of Trimble's photogrammetric software, and this brand, or this Inpho 5.4, is simply combining all the software that we have, so Applications Master 5.4, AutoVista 4.6, and the SCOP family of programs that are, of course, still available separately as modules. But yeah, so Inpho 5.4 is just the brand of the complete photogrammetric suite. How will I get Inpho 5.4? I already said, well, all our users with a valid maintenance contract will get that for free. I guess they already should got their emails with the new licenses. And, well, new customers, of course, can contact our Inpho sales team. And whenever you want to just try the software, you can download the software from our internet site, and it will run in a demonstration mode with some restrictions, or again, contact our sales team to probably get a test license for a couple of days or weeks. Then talking about the compatibility with the older versions, the new version, the 5.4 version, is, of course, downward compatible. However, it's essential to have the latest patches of the old software installed. So if you want to run the 5.3 and the 5.4 versions together, just be aware that you have the latest patch of the old version installed. Now, where do I get more information? I already said that in the beginning, so especially I would recommend to check the release notes for the latest release, which is also available from our website. And one important thing that I want to mention here is the question, is Inpho 5.4 still running on 32-bit operating systems? And already with the last version, with the former version, with the 5.3 version, we said that this will be the last version running on 32-bit operating systems. It was just the masses and the complexity of all the data that we have to process nowadays that told us, well, a 32-bit operating system does not make too much sense anymore to produce all the data. And so we decided to have the 64-bit version now as the only version available. Okay, now to just summarize what you have seen in this webinar a little bit, just 3 points. An image is worth 1,000,000 points. So I recently have heard a more or less new term about the Info Cloud. So I like that term very much. So one point is having much more information than just X, Y, Z coordinates. So there's much more information in all the data that we can process, and especially now with our new point cloud that we can extract from imagery, we are really happy that we get so much information out of images. Then the second point, getting a handle on the data. I was talking a lot about our parallel processing capabilities, about the support of new data formats, and so on. So it is really essential, of course, that if you have those huge data sets and if we produce those new point clouds, we really get a good way to handle the data. And we did a lot of improvements in our software to do that or to cope with all those things. And finally, go with the workflow. I hope, at least in the use case, for example, you have seen that the geospatial division really has a good workflow from A to C. So we have all the modules available to establish that complete workflow. And so that's bringing me to the end of my webinar, of my presentation here. And now I'm open for any questions that you might have.
Thank you, Thomas. We will go through the questions. There are already quite a number of questions that have come in during the webinar, and I will start from top. So the first question that came in, one of the first questions was whether we actually recommend doing DEM generation using also medium format cameras.
What means do we recommend that? In any case, it's working with medium format cameras as well as with those large format cameras. It's always depending on the quality of the images you might get. So if you have a good metric medium format camera with a stable lens and so on, like for example our own medium format camera, then of course, that's a good option that you have, that you can really use our MatchT software to create these dense DSMs.
Okay. Another question was whether or which, let's say, point resolution we would get from 25 centimeter resolution imagery. So what point density could we generate from that?
Like I said, so these new matching algorithms are able to extract point clouds with a density of up to 1 pixel. So if you have 25 centimeters ground resolution, then you also get a point cloud that has the same density, so also 25 centimeters resolution. Again, the default that we are setting for that would be 3 pixels, just to keep the number of points a little bit lower that we are extracting. But if you don't care about that, so if you're able to handle all the large data sets for your storage or whatever, if you want to have that high density, you can go up to 1 pixel ground sample distance.
Okay, one related question would be whether the point cloud is generated as a regular grid, or if it's using, or it's done based on terrain features. So meaning that if we would have sharp edges, for example, those would be, I don't know, pointed out by the cloud, by the points.
Yeah, again, so these point clouds that we're extracting are based on the pixels. So if I'm creating for every pixel one height value, then it's actually a grid that we're creating.
Mm-hmm. One question is why would we need LiDAR if we can do this with imagery? Quite a provoking question, I guess. Okay.
Well, in fact, so what I was saying is that the matching might be an alternative to LiDAR. Of course, we have extremely good point clouds that we can extract from images. However, look, for example, at forest regions. In a forest region, looking at images or using images for DSM extraction, you will never get the true ground. So there's no way to penetrate through the forest to the true ground. And this is something, or that's an application where, for example, a laser scanner still has a huge benefit. So you have the multiple returns for a laser scanner to extract even in dense forests a true ground. But so like I said, so there might be applications where you still need a laser scanner but in many cases, this automatic matching can really replace the laser scanner, or it can be a low-cost alternative, like I said. So just for an example, here in Germany, the state authorities, they are using image-based DSM extraction to update their LiDAR database. So they're flying with their LiDAR once or twice, whatever, creating their height database, and then whenever they are flying for creating new orthophotos, they're just using the same photo flight to just update in smaller parts their existing height model. And that's, for example, one of the benefits that you really have now, being somehow in terms of accuracy comparable to LiDAR data.
Okay, I have a related question to that. Question would be whether we have compared the LiDAR Z accuracy, so the accuracy in the C elevation, with medium format camera derived DTMs.
That's more or less comparable. Again, depending, of course, on the flying height that you have. So there's a geometric component that you have to look at. In any case, though, in the data that we have investigated so far, we have seen that usually, when I was talking also about the noise in the point cloud, we have from imagery a better noise ratio than what we have from a laser scanner. So in these terms, you could say that, well, in some cases, you even have a better height accuracy than what's coming from a laser scanner. But again, here when we compare laser data with DSMs coming from imagery, we have to still remember that if you have bad image quality, then that of course will affect the matching. So really you have to use a good medium format camera in order to create that high accuracy point cloud. If you have blurred images, if you do not have any forward motion compensation, things like that in your camera, then most probably your point cloud will not be as good as a LiDAR point cloud.
Okay, now I have some hardware-related question or system-related question. One would be, how much computer memory would we need for matched TDs nowadays? So is there a limit like a lower limit to computer memory or an upper limit for?
I would say with those 64-bit operating systems anyway, you should install about 8 gigabytes memory. So that's the minimum requirement that we would recommend for all our products, basically. And, well, if you do a lot of manual editing and loading huge data sets into, for example, our DTM editing tools, then probably I would go even higher. So my recommendation would then be to use even 16 gigabytes of memory. But like I said, so 8 gigabytes would be the minimum that I would suggest.
Sounds reasonable. One question was, how many cores can matched TDs use now, and whether there's a limit to multi-core usage? Yeah.
At the moment, it's like that matched T, for example, is using 5 cores with 1 license. If you want to use more cores than that, it's actually a distributed processing license that you need to purchase, and the distributed processing licenses, they're costing about a third of the standard price.
One question back to the flight conditions for generating an elevation model. The question was, what minimum overlap will we need to get a 1 point per pixel setup? Okay.
Well, say the minimum overlap that I would suggest is 60 by 60% overlap, so 60% end lap, 60% side lap. If you have more, if you have 80%, say the features in the photos are looking even more similar, so it might be a benefit to even go for 80 by 80%. But like I say, so 60 by 60% is enough that you need. And actually, those 60 by 60% is necessary just to look into those narrow streets. So it's not a necessity from a point of matching. It's just a necessity to really have visible areas available. So if I have a densely built up area and tiny streets, and I really want to extract the points on the ground, then you need those 60 by 60% overlap.
The question that I have here is whether we have generated the true orthos of 20 centimeters, which we've shown in the presentation, without building vector extraction in stereo.
Yeah, like I said, so this example that I showed right here was completely automatic. So there was not at all any manual interaction done. So no digitization of rooftops and so on. It was really straight using the point cloud coming from HT DSM and using that for true orthophoto computation.
Okay. One more question would be whether it would be possible to use the software on 1 meter or 50 centimeter satellite imagery, and if so, whether the results would be good enough to extract buildings and building height.
Actually, right now it's a little bit difficult for me to answer that because that's just a test that we're currently doing. The results are looking promising. So the colleague of mine who's doing that test was using 50 centimeters resolution satellite imagery, and well, the buildings were modeled quite nicely. And yeah, but that's more or less all I can say about that. So I cannot give a definite answer to that, at least not at the moment. But if you need some more information on that, you can always write an email to me, and I can get back to you answering that question a little bit later.
Mm-hmm. One compatibility question is whether CMF batch files produced for SCOP++ 5.4, whether those will also run version 5.5 without problems.
They should. So there should not be any problem in that. So like I said, so everything is downward compatible, and so there should not be any problem. Mm-hmm.
A bit more technical question here. What is recommended with using the new AutoMaster copy files to cache option? Does this help to increase the processing speed or leaving the data on the network?
Well, of course, those caching options they're influencing the speed, but well, talking about the numbers in detail, I would have to look up that myself. So what are the recommended numbers here? But say the defaults that we normally specify, they serve the best for the process. So yeah.
Mm-hmm. One more technical question coming up, which is the preferred operation system platform for Inpho?
The operating system, the preferred one is using Windows 7. Of course, so that's how we equip all our computers here. So we have Windows 7 with 64-bit. Like I said, so the new software anyway is running only on 64-bit. We also have some computers still running Windows Vista. But yeah, so maybe with Windows XP 64-bit, there might be one or the other issue with the graphics drivers. So it's not really our software who's having the limitations there. It's more the stereo drivers of NVIDIA who's sometimes causing trouble. But yeah, so our preferred operating system will be Windows 7 now.
There are still a number of questions which are unanswered, and we will make sure to answer these questions using email and getting back to the people that ask the questions individually.
Okay.
With that, I would like to thank everyone for this webinar, and also thank you, Thomas, for spending the time and guiding us through the new version. And of course, hope to see most of you back in the next upcoming webinars that we will provide and that we will inform you about. Thanks a lot, and goodbye.